Hello, third grade, and welcome to lesson 3-7. We're going to be working on repeated reasoning for this lesson. So what that means is you're going to take what you already know, you're going to use your reasoning skills, the facts that you know, and use them to help solve different kinds of problems that you come across.
How can you use repeated reasoning when multiplying? Think about this question during the lesson. Ellie wrote the equations below to find the total number of squares in each of these rectangles. Look at the equations. Known facts with which factors are used repeatedly to find the products. Think. What do I need to do to complete the task? I need to see if there are known facts that can be used repeatedly to find other facts. Let's look at equation A. How do you know that equation A is correct? First, multiply 2 times 6 to get 12. Then, multiply 1 times 6 to get 6. 12 plus 6 equals 18. So, equation A is correct. It shows using a 1's fact and a 2's fact to multiply. What does it mean to use known facts repeatedly to find other facts? It means to use known facts to find the products of unknown facts. Think, how can I make a generalization from repeated reasoning? I can look for repeated calculations. I can make generalizations about the repeated calculations. I can test whether my generalizations will work for other numbers. Here's my thinking. I can see that the factors 1, 2, and 5 are used repeatedly. I can see two generalizations. I can break facts with 3 or 4 into 2's and 1's facts. I can break facts with 6 or 7 into 5's, 2's, and 1's facts. I can test this with other facts. How do 3 times 5 and 6 times 7 show that the generalization is correct? Both are broken into other facts that use 5, 2, and 1 as factors. Now you know how to use repeated reasoning when you multiply.
Good work.
All right, now that we've gone through the video part of our lesson, I'm going to go ahead and show you guys our notes for today. We'll go over the notes section and then we're going to get started on our guided practice questions. Now for our notes for today, we're working on repeated reasoning and we're going to use what we know of our multiplication facts to find missing factors and work backwards when we need to. So for example, if I know that 6 times 7 is equal to 42, I can find the missing factors below. So if I have an equation like this one, and they give me a clue, they told me 2 is one of my factors, I need to find out what the other one is. So I know that they distributed the 6 into a group of 2 and another number. So I need to figure out 2 plus what number is going to give me 6. Now, because I know my basic addition facts, I know that 2 plus 4 is equal to 6. So my missing factor over here is going to be the 4. So 2 times 7 plus 4 times 7 is equal to the same thing as 6 times 7, which is 42. Now, I can also use a different example to go about this. If I know, for example, that 7 times 7 is equal to 49, I can find the missing factor to complete this equation. Now, because they left it blank, and because I know I need to distribute this first 7 into groups, I can distribute it many ways. So I know there's a lot of different ways that I can make 7. I can do 3 plus 4 or 4 plus 3. I can do 5 plus 2 or 2 plus 5. I can do 6 plus 1 or 1 plus 6. All of these are different ways to make the number 7. So if I'm looking for a way to fill in this equation, any one of these can complete the equation. So I can do the 3 and the 4. 3 times 7 plus 4 times 7 is 49. I can do the 5 and the 2. 5 times 7 plus 2 times 7 is also equal to 49. And I can use the 6 and the 1. Now, if I want to check my work and multiply these out, I can go ahead and do the math just to make sure that my answer is correct. So I know 3 times 7 is 21, plus 4 times 7 is 28. I know 21 plus 28 is going to equal 49. Over here, 5 times 7 I know is 35, plus 2 times 7 is 14. This is also going to be equal to 49. Then I can do 6 times 7, which is 42, plus 1 times 7 is 7. This will also equal 49. So I can use any one of these. A lot of times, if they're asking you to just fill in an equation like this, there's usually more than one right answer. There's more than one way for you to be able to solve. Now let's go ahead and take a look at our guided practice, and we're going to work through this together. Let me bring over my book so that you guys can see the questions, and we will solve them as we go. So for number 1, it says, Ricardo wrote the equations below. Which factors did Ricardo use repeatedly to find the product? Make a generalization. Let's go ahead and take a look. Now for number 1, in our guided practice, we can see that he did 3 times 8, and he split it into 2 times 8 plus 1 times 8. So we know that he distributed the 3 into a group of 2 and a group of 1. For 3 times 7, he did 2 times 7 plus 1 times 7. Again, he distributed that 3 into a group of 2 and a group of 1. And then for 6 times 3, he did 6 times 1 plus 6 times 2. So again, he used that 1 and that 2 to distribute. So the generalization that we can make from this, and the factors that he used repeatedly were 2 and 1. He used the factors 1 and 2 repeatedly. Find the products of his equations. Okay. So we can generalize, or we can say that I can break 3s into groups of 1 and 2. So that's the generalization we're able to make from this. I can generalize that facts with 3 can be distributed into groups of 1 and 2 to solve. All right, so that takes us through number 1. He used the facts 1 and 2 repeatedly. Repeatedly means over and over again, to find the product of his equations, right? He took the 3 over here, he broke it into 2 and 1. The 3 over here, he broke into 2 and 1. The 3 over here, he broke into 2 and 1 again. we can generalize, or we can assume that because he was able to do this multiple times correctly, that anytime you're working with 3 as one of your factors, you can break it apart into groups of 1 and 2 to solve. For number 2, complete the equation to test whether your generalization is true of other facts. So 3 times 9. Now we're going to break it apart the same way that he did here. So we're going to take that 3 and we're going to decompose it or distribute it into these 2 parentheses into a group of 1 and 2. So let's write down our equation. 3 times 9 is going to be equal to what? So we're going to stop and we're going to figure out how we're going to distribute this the right way. Something times 9 plus something else times 9. So we're going to test the theory that we were using, that generalization. We're going to test it and see if our answer will hold true over here and see if we're able to find the correct answer. So 3 times 9, we're going to break it apart the same way into a group of 2 and a group of 1. So this is equal to 2 times 9 is equal to 18, plus 1 times 9 is equal to 9. And this all together is equal to 27. So we know 3 times 9 is equal to 27. Now for the remaining independent practice on this page and onto the back page, you're going to be completing these questions. Use the space they've provided for you. Write neatly and carefully. Write smaller whenever you need to make your work fit. And please make sure you're using good handwriting. If you have any questions about this lesson, let me know. Otherwise, I hope you have a great day. Take care. Bye-bye.